Here's question 11, and it starts off with just subbing into your calculator. Okay, so when you sub in x equals 25, plug all that into your calculator, the value that you get would be 21,877. Okay, part A is not interesting, that's why I kind of skipped it there. Part B though, by factorizing this expression, show that your answer to A can be written as the product of prime factors. Okay, that can be quite intimidating. We're talking about primes, we're factorizing what? Let's just worry about factorizing this expression first, and then we can come back to seeing how it shows it's a product of prime factors. Okay, so first we need to factorize. Okay, and as we usually do, we do 35 times 48. Okay, and that is 1,680. Okay, so we need to find two numbers that times together to equal negative 1,680 and add together to equal positive 2. Okay, now this is a quite tricky concept to think about. Okay, you need to be smart when you do this. All right, well, we need the numbers that add together to equal positive 2. So they've got to be close together. Okay, and as these numbers in the number line have got to be very close together, okay, only a difference of 2, then it's almost like finding this square number. Okay, what number squares to get this? Because that is, well, square number is the smallest difference. They've got a difference of 0 between each other. Okay, so what number squared gives us 1,680? So you can square root it, and that can be your starting block, and then you can work around there. Or here, I know that 40 squared is 1,600. Okay, and that's very close to it, so I'm going to divide by 40 and see what I get. So when you divide by 40, you get 42, okay, which is exactly what we want. Okay, but here's the method behind it. Instead of just saying divide by 40, and then you're like, all right, you've got the answer. Great, but how do I create that myself? This is the thinking behind it. This is why we've divided by 40. Okay, now that's the figuring out the breakup. Sorry, this should be a negative 40x. Negative 40x plus 42x will give us a positive 2x minus 48. Okay, so we've broken it up into our 4 terms. Okay, now we need to find us in our double brackets. Okay, and we simply can't just write 35x and x like we used to do. Okay, because we've got 40 and 42, and those none of those divide by our 35. Okay, so we've got to think of something a bit different. Okay, we need to find two numbers that you can divide 35 by, that then also one divides 40, one divides 42. Okay, and there's not many that divide 35, so you can kind of do a checklist, or 7 times 5 is one that comes to mind. Okay, and 5 divides 40, 7 divides 42. You'll see in a second why that's so important. Okay, so let's label our 7x and label our 5x. Okay, now when we expand this, we'll get our 35x squared, and then we need to get our plus 42x, take away 40x. Right, that's how we need it. We're kind of reverse engineering this. So when we have our plus 42x, we need to add 6 here. And when we have our minus 40, we need to take away 8. Okay, and just as a final check, is minus 8 times 6 negative 48? Yes, it is. Okay, so 7x minus 8 and 5x plus 6. Okay, this is the factorization of our formula. Okay, perfect. Now, what did the question want? Okay, we've done the factorization. Show that the answer to A can be written as the product of two prime factors. Okay, it can be written as a product of two prime factors. So 21877 was our answer to A. Okay, and how do we get that? Well, if you were to sub in x equals 25 into here, okay, then you would get times those together, and that would equal 21,877. So they've given you a hand here. They've told you this is the method that you need. Okay, but how can I convince you that this then shows two numbers that can be written as a product of two prime factors. Okay, why is 7 times 25 take away 8 prime, and why is 5 times 25 plus 6 prime? Okay, why are these two prime? Well, and that's about why it's going to have to. Okay, they're going to have to be prime. Okay, because you're showing something. Okay, so let's just sub in, see what you get. So 725 take away 8. What does that give you? That gives you 167. And then you have 525 plus 6. That gives you 131. Okay, so these are your two product of primes. These are two numbers that times together. You times them together, you get 21,877. So that factorization has taken away the kind of trial and error. Now we need to make sure we can prove that both of these are prime numbers. Okay, and the easiest way to do this, okay, would be to check. Okay, 167, okay, cannot be divided by, okay, well, we know it can't be divided by 3, okay, because 150 is divisible by 3 and 17 is not divisible by 3, so it can't be divisible by 3. Can't be divisible by 4 because it's not even, so not even really quite checking that, sorry. Can't be divisible by 5 because it doesn't end in a 0 or a 5. Can it be divisible by 7? Okay, well, we have 70, 140, okay, then 27 is not divisible by 7, so it can't be divisible by 7, okay, skip 8, skip 9, okay, 11, okay, can it be divisible by 11? Well, we've got 121, 132, which is, sorry, 11 squared, 143, 154, 165. Okay, so it's not divisible by 11. Is it divisible by 13? Well, 13 squared is 169. Okay, so we passed 167, so that's kind of our proving that 167 must be prime because it's only divisible by 1 and 167. Okay, and then we can then do the same thing here for 131. So 131 cannot be divisible by, well, 3, right? Because 120 is divisible by 3, and then 11 is not divisible by 3. 5 doesn't end in a 0 or a 5. 7, okay. Well, what do we know? Well, we know 140 is divisible by 7, so that must mean that 133 is, so then 131 isn't. So 131 isn't divisible by 7. Okay, we don't look at a 9, we look at 11. Okay, yet again, 121, 132, and then 13. 13 squared is 169, which is greater than 131. Okay, so here we prove that 131 is prime. Okay, so both 131 and 167 are prime numbers, and when you times them together from this factorizing, we know that you get 21,877. Okay, so quite a tricky question, quite an interesting question, and let me know if you have any questions.